So in this video, we'll concentrate on descriptive statistics. So what is descriptive statistics? So basically, these are variables that help us summarize the data that we have, which can either represent the entire or the part of the population that is called the sample. Now, considering that we did understand populations and samples, we're going to move ahead and basically, we see here that there are two major branches of descriptive statistics, one being measures of central tendency and the other being measures of variability or spread. We want to look into the measures of central tendency first. So measures of central tendency when this particular phrase, if this particular phrase is set to some, the first thing that comes to that particular person's mind is that it's something related to something that's in the middle, center. So when we say measures of central tendency, we basically are talking about three things: the mean, the median, and the mode, the three M's. So the mean is nothing but the average of the data set, which is also sometimes referred as the expected value. It's, it's basically the average of the population or the sample. The value gives us an approximate idea of what the entire data set looks like. So on the right, we have an example where there are three bins and each bin has a few balls. Now, the first bin has 5 balls, the second bin has 6, the third bin has 7. If I ask you to find the average or the mean of this particular question, it's a basic addition and division problem. We add in 5 and 6 and 7 and then divide it by 3 and we get 6. It's as simple as that. So that's what mean generally is. So this is how we write the formula for mean. So there are different notations that I'm going to explain. So this is x bar. We call this x bar, which basically represents mean as written here. Then we have the summation sign and x. This is called sigma, which basically means some direction, divided by n, which represents the number of observations. So if this is difficult for you to understand and remember, the basic thing is summarization of the values divided by the total number of observations gives you mean. That simple as that. The question says that there are three baskets, A, B, and C, and they have 12, 14, and 22 apples respectively from three different locations. Now the farmer, Mr. Orchard, a wild name, to be honest, wants to know how many apples on an average does he have. So it's a basic sum. We have the numbers here. We have 12, 14, and 22. We need to add them up and divide by 3. And we get the answer as 16. Simple, straightforward. Let's look at a different example. So you can see that the question is same, but there is this one value which is a bit different. It was 22 earlier, it's 220 now. Well, that's not a typo. It's done intentionally. So I would really want you to pause the video here and solve the sum out yourself. Considering that you did solve the sum, let's look at the answer. So the answer you should have got is 82. Now you see that it's way bigger than what we got earlier. And just because that there is this one particular uh, value that pulls the mean towards itself. Well, the mean is the average, or it says that, okay, if you have three places on an average, you get somewhere around 82 apples from each place. Well, it doesn't seem so. We have 12 from A and 14 from B. So is the question wrong, or did I teach the wrong formula? So don't get scared. The question and the formula is right. So you and 82 is the correct answer. But if you want to see, is it the actual correct answer? What I mean by that is 82 or the mean value represents that on an average, uh, this is the value that you should get out of each basket, or approximately this is the value that will be near to the values from all the baskets. But that doesn't seem to be the case here. We have 12 and 14 in one of the baskets and 220, which basically says that this basically doesn't make sense. Correct. So why is this happening? So the value over here, 220, is called an outlier. So an outlier is something that doesn't fit into the general stream of data. So when you open a particular shoe rack and you see shoes that range from say 6, 7, and 8, it's understandable that okay, these are normal shoe size. But on the right, you see that there's a shoe that is really small, say a size that is round about 2, or you see a shoe that is really big, say a size of 13, which is enormous. And because of these points, the entire data is kind of shaken up, and the mean goes on to bend or is pulled towards these outliers. So are we done here, or does the mean doesn't make sense? It's not that. We're going to look into how to solve this problem in the next video.